Welcome to my channel. This video is a tutorial on understanding Euclid's division algorithm. Before you watch this video, please remember to watch real numbers part 1 and 2 posted in this channel earlier to understand the concepts of Euclid's division lemma. The equation what you see on the screen is what is Euclid's division lemma, which is discussed in the earlier videos posted in this channel. So here A is equal to BQ plus R, where 0 is less than or equal to R less than B, where A is the dividend, B is the divisor, Q is the quotient, and R is the remainder, which an example is given. So let's observe what an Euclid's division algorithm is. It is to obtain the HCF of two positive integers. So we'll be following all the steps to find out the HCF of two positive numbers. It's called an algorithm because it has a number of step-by-step procedure for solving or finding out the HCF of two numbers. Let's go ahead and do this algorithm on a particular question to find out the HCF between two numbers. So now let's observe a new way of finding the HCF of two integers. So this way is what is called as a Euclid's division algorithm. Okay, because how do you find the HCF? There are different methods by which we find the HCF of two numbers. Usually in earlier grades, what is being taught is to find the HCF using the prime factorization method. So, but when you use the prime factorization method, when the numbers are really smaller, it's easier. But what happens if the numbers are really larger? So that is an alternative method which you call it as a Euclid's division algorithm for finding the HCF or the highest common factor between two integers. We are going to learn how to do this. So now for instance, we'll consider two numbers. Let it be say 210 and 55. Right? The first step you have to do is like check if 55 divides to 10 completely, or otherwise the remainder after division is 0. So let's divide this. 210 I'm going to divide with 55. So here 210 is the dividend and 55 is the divisor. I'm going to divide it. So how many times 55? I get a number closer to 210. So when I say 3 times 55, so I get it as 165. Right? We'll subtract this. So I get a 5 and then a 4, right? So now see here, the remainder obtained is 45. It's not 0. So 55 is not the HCF of 210. So we have to go further on. So when I use the division lemma, which you learned in earlier videos, so 210 I can write it as is equal to 55 times, right? 55 times 3 plus the remainder is 45. Now the next step is that you have to highlight this 55, okay, and 44. Consider this two, right? Now 55 I can write this as 55 is equal to, right? Consider this 45. 45 times what? So I'm going to divide 55 by 45, right? So how many times 45 I get? 1 time 45 I get a 45 and 10 is the remainder of 10, right? So 45 times 1 plus 10, right? Again I'm going to consider this divisor which is 45 and the remainder which is 10. So now I can write this divisor, you take 45, this is equal to 10 times, right? The remainder times 10 times what? So I can divide this 45. When I'm going to divide with 10, 4 times 10 is what is 40 and I get a remainder of 5, right? So I can write 10 times 4 plus 5. Now consider this divisor 10 and the remainder 5. So 10 is equal to, I'm using the division lemma here, Euclid's division lemma. So 10 is equal to remainder, right? 5 times what? 5 times 2 plus 0, right? Now I got 0 as a remainder. So at this point, when you get 0 as a remainder, what is the divisor obtained? That is a HCF. So I can write the HCF of these two numbers. So HCF of 210 and 55 is equal to 5. The beauty of this algorithm is that when I find the HCF of all of this, so if I say the HCF of 210, 55 and HCF of 55, 45 and HCF of 45, 10 and again HCF of 10 and 5, all this will be equal to 5. This is what is Euclid's division algorithm way of finding the HCF of two integers. Here is an application question on Euclid's division algorithms. The question is, the length, breadth and height of a room are given respectively. Determine the longest rod which can measure the 3 dimension of the room exactly. So for easier understanding, I'm just going to use smaller numbers. Maybe we'll take it as 20, 15 and 25 as the dimension of this cuboid, say length, breadth and height. So let us do prime factorization of these three numbers to find the HCF. So 20 is 5 times 4, right? And 15 is 5 times 3 and 25 is 5 times 5. So now what is the HCF of all this is 5, right? So now the question is, what is the longest rod which can use these measurements for the 3 dimension of the rooms exactly? So I should find the length of a rod which can measure all these dimensions perfectly. So here the rod size should be, length should be 5. So for length, which is 20, how many rods of 5 centimeter I need? I need 4, right? I need 4 of the same length. If I want to measure the breadth, say 15, so I need 3 of this kind. All this is of length 5. If I want to find the height, I need 5 of this length. Hope you understood this. So basically what you have to do with these 3 measurements is to find the HCF of these 3 numbers will give you the longest rod which can measure the 3 dimension exactly. Fine. So let us go ahead and find the HCF of this. So here it's given as length is equal to 8 meter 25 centimeter. So have you noticed that there are 2 units? We need to convert it into a single units, right? So 1 meter is equal to 100 centimeters, right? So 8 meter I can write as 800 plus 25. So this is equal to 825 centimeter. Then breadth is equal to 6 meters 75 centimeter. This is equal to 600 plus 75. This is equal to 675 centimeter. And then height is equal to 4 meter 50 centimeter, right? So this is 400 plus 50. That's equal to 450 centimeter. Now what you have to do here to find the longest rod, you have to find the HCF of these three numbers. I'm going to find the HCF of these three numbers. So first let me find the HCF of 825 and 675. What do I have to do here? Using Euclid's division algorithm, I should write 825 is equal to 675 multiplied with, we know it is only 1 times, plus what will be the remainder? When you subtract this, I get 150, right? Now I should take this divisor and this remainder. So I can write 675 as 150 multiplied with how many times? 4 times. And then plus 75. This is the divisor. And here is the remainder. So 150 will be equal to 75 times 2 plus 75 times 2 is 150 plus 0, right? So once when you get the remainder as 0, what is the divisor obtained will be the HCF. So the HCF of these two numbers I can say 75. Now what you have to do is find the HCF of 75 and the height. What is the height here? 450. Now you don't have to really use a division algorithm because the reason that 75 is a multiple of 450, right? So 450 is completely divisible by 75. So the HCF is equal to 75, right? So I can conclude that the length of the longest rod is what here? 75 centimeter. Keep watching the videos posted in this channel for the continuation of this lesson. If you find this video informative, please remember to subscribe, like and share this video.